Okay, so lesson 6.3 is asking us to kind of use what we're learning already, things that you already know, and kind of apply it and find values. Okay, so the first set is saying, what are our values with our unit circle where r is 1? So if our radius is 1, here's what happens. This idea that sine is y over r really just means it's y over 1 in a unit circle situation, which really means y, your y value, and all of those coordinates that we talked about, that's your sine value. Your cosine value is going to be x over 1, which is just x, and then your tangent is going to be your y over your x, so that can kind of stay. It doesn't simplify. All right, same thing for the opposite values here, those reciprocal values. This one would be 1 over y. This one would be 1 over x. And then you've got your x over y for your cotangent. Okay, so what does that mean in an actual problem? So here's an actual problem. They told me that my point is 24 over 25, comma, negative 7 over 25. Okay, so if I'm finding the sine value of that, I'm looking for the y value. Well, that would be negative 7 over 25. So that makes that really easy if I just know it's my x's and my y's, right? All right, and then my next one is my x value. So that is 24 over 25. Tangent would be the only weird one that you really have to figure out. In most cases, it's the weird one. So I've got a negative 7 over 25 over a 24 over 25. So what does that actually mean? That means I've got negative 7 over 25 divided by 24 over 25. Well, that means that I have negative 7 over 25 times 25 over 24 if you flip that. So then those will cancel, and I will end up with negative 7 over 24. Okay, so here's an easier way to look at that. So if you go back up here, I have a negative 7 over 25 over 24 over 25. Because these denominators are the same, when it flips, they will cancel. So I just always think of it as my numerator over my numerator if the denominators are the same, okay? All right, so there's those three values, and you should know by now that these other values over here, this cosecant, secant, and cotangent, are just the reciprocals of these. So I don't have to even think about this unit circle at all. All I have to think about is flipping this over. So negative 25 over 7, 25 over 24, and negative 24 over 7. So those are those three values. Okay. Number 5, this one to me is kind of the weird one. So 25 says, I want to know what's going to happen if I add pi, or if I subtract pi, or if I make it negative, or if I make it negative and then do something with pi. So let's just talk about first what this looks like on the unit circle. So if I'm talking about, let's say I'm talking about this point right here. If I add pi to that, so let's go back to 0 for a second. This over here is pi. So 0 plus pi is exactly 180 degrees, right? So you're adding half the circle to it. So if I did that here, and I said this plus pi, that would put me over here. So exactly the diameter across, right? Same thing with this one. So this one, if I add pi, I would end up right here, the exact opposite side. So what does that do to your coordinate points? Well, if I look at this one was square root of 3 over 2, comma 1/2. Well, when I put it all the way over here on the other side, it just made the two coordinates negative. Otherwise, they are the same. So it switches the signs. So if you add pi, it's going to switch the signs of your coordinate values. If you subtract pi, that means I'm going this way, pi, but I'm still going to end up at the exact same point. So it's going to do the same thing. So when they say plus pi and then minus pi, I should get the same answer for both of those. And all that's going to do is change my signs. So if my coordinate was 3/5, 4/5, this coordinate would be negative 3/5, negative 4/5. Same thing with this one. If I subtract pi, I'm going to end up at negative 3/5, negative 4/5. All right, This one, if I make it negative, if I make that t value negative, here's what's happening. It's just going to reflect it over the x-axis. So it was here, now it's going to be here, okay, if I'm talking about this particular point. So let's say I'm talking about this point. This one would end up here. So from here down to here, I'm just reflecting it over the x-axis. So this one reflected over, let's see what happens to the coordinates. This one was both positive. This one is the same values, but a negative y value this time. So it's just going to change my y value. It's going to change its sign. So if it's negative, it's going to make it positive. If it's positive, it's going to make it negative. So in this case, I had a positive y value. So this one would end up 3/5 still, but now negative y value. Okay, so then this one is asking me, what happens if you make it negative like you did there, but then you also subtract pi? So let's go back to this example again where I'm right here. If I make it negative, I'm flipping it over the the x-axis, sorry. That puts it here. Then I'm going to subtract pi from it. That means I'm going to go all the way around to the other side of the circle. So that's going to take it from here to here and then across the circle to there. That means my y values and my x values now. So let's see, I totally just messed that up. Let's look at that again. I'm sorry. Okay, so I am flipping it over this axis, but I'm also, I disagree with this statement. Oh, I'm sorry, I went to the wrong one. I was going over here. I'm supposed to be going here. That's why that made no sense to me. So I'm gonna put you in my brain for a second. I flipped it over the x-axis and then I put it up there and that switched my values. And I know that's not the way that was supposed to be done. What happens is when you flip this over, it changes that y value to a negative or makes it from a negative to a positive. So it changes your sign of your y value. Then when I do pi, remember back from that other one, I change both values. So that made it, instead of a positive, it made it a negative for my x value, and then instead of a negative, it made it a positive for my y value. The easiest way to do it in this particular problem, because that was really confusing and I didn't help with that, so I apologize. In this problem, the easiest way to do it is to look at this value that you just found. So I just did negative t, and then change those values like we did back here. So both of those were positive. We made them negative for these two. I'm going to do the same thing here. This is my new point because it's got that negative t with it. Now I'm going to change my values to a negative 3/5 and a positive 4/5. Okay? Okay, if you get stuck on that one, let me know. I believe it's number 7 in your homework assignment, so I don't think I made that very clear when I was talking about it, so if you struggle with number 7, let me know. Okay, number 11. And these are from your book. I'm just doing these because I didn't feel like the examples in the textbook were really as good as the actual problems. So I'm just doing some of the problems with you. So number 11 says this. It says, let P be a point on the unit circle that corresponds to T. Find the coordinates of P and the exact values of the trig functions of T whenever possible. So they want me to find sine, cosine, tangent, cosecant, secant, cotangent. And they also want me to find those coordinate values. Okay, so I need to know what is my x comma y, right? So on your problem in number 9, this is the one I assigned, it's asking about 2 pi, which is, let's go back to our unit circle here. 2 pi is right here, right? So they're asking about this point right here. So the coordinates they're asking about are 1, 0. And then you can find your sine and your cosine and your tangent and such from there. If it asked you about something that is not specifically on here, I want you to think about it as a fraction. So that's where I'm going to think about mine. So I've got, on number 11, part A, I've got 3 pi over 2. That actually does show up on my unit circle. It's right here. Okay? But let's say it didn't. I want you to just think about this as 3/2 is the same thing as 1 1/2. So if I have 1 1/2 pi, I want you to think about that on a unit circle here. This is pi, right? So this is 1 pi. And then if I go another half half a pi is right here. So that's 1.5 pi's, or 3 pi over 2, okay? All right, so that ends up at 0, -1. That's the first thing I need to give them, is that coordinate point. So 0, -1. That's my first answer. Okay, then I need to give all of my trig values. So the sign, once you have this, so I was gonna write this in, that this is pi and then half more. Okay, so once you go into these, you just need to remember that sine is your y value, cosine is your x value, tangent is your y over x. So if sine is my y value, that's -1. It's right here. Cosine is my x value, that's 0. Tangent is this over this, so -1 over 0. Well, this one's weird. If you're dividing by 0, that is undefined, which they, in your book, they just put u. So I'm just going to have you put u for that. Okay, and then I'm just going to do the reciprocals for these. So the reciprocal of -1 over 1 is still -1 over 1. So that's still -1. Secant would be 0 over 1. Flipped would be 1 over 0. That's undefined. And then cotangent, it was -1 over 0. So now it's 0 over -1. 0 on top is okay. That's just 0. So that value is 0. So these 4, I don't know why I just said 4, these 6 values are part of your answer. So you have 7 answers just for part A on number 11. And your problems, I believe it is probably number 13 or something that's very similar to this one. All right, I already said it was number 9. That's the one I assigned you. Okay, part B, if I'm at -7 over 2, okay, here's what that means. That's the same thing, 7 over 2 is the same thing as -3.5. Okay, so that means I'm gonna go pi once. Oh, I'm sorry. I'm going the wrong direction. My brain is not with me today, guys. I should have videoed this tomorrow. All right, so I'm starting here at 0, and I'm going to go -3 over 2. That means I have to go this direction. So there's pi once, twice, 3 times, and a half. So I end up right here at this point, which on your unit circle is the same thing as pi over 2. So really, this is the same thing as pi over 2. Either way, my coordinate point is 0, 1 there. So 0, 1 is my coordinate point. That's my first answer. Okay, my second answer, my sine is my y value. That's 1. My cosine is my x value. That's 0. This one, again, this time is going to end up 1 over 0, which is still undefined. This one's still going to be 1, because 1 over 1, reciprocal would be 1 over 1. This one, 1 over 0, which is undefined. This one, 0 over 1, which is 0. That one's okay. So I ended up with pretty similar answers on both of those. Okay. Number 17. So now I'm going to switch to this idea. We need to talk about formulas for negatives, and they have this in your book. So this is just the rule for when you have a negative t, what happens? Well, in this case, it's the same thing as just saying, what's the sign of that value? And then put a negative on the front. This one does not end up that way. Cosine of a negative t is the same thing as a cosine of a t. So when you go and look at the values on your unit circle, this should make sense, okay? If I have a tangent of a negative t, that is the same thing as a negative tangent of t. And these follow. So it's really just this section right here that when you have a negative value, it doesn't matter. You're still going to end up with cosine of. It's the same as the positive value. So same thing with secant. These two are the two interesting ones. The other ones, just make them negative. So when I'm talking about this first one right here, they said sine of -90 degrees. Well, my rule is that's the same thing as negative sine of 90 degrees, right? So now let's look at our unit circle for that. So if I'm looking at sine at 90 degrees, remember sine is your y value. So if I'm doing a negative y value, that's -1. So a negative sine of 90 is -1. Okay, the second one, negative cosine of -3 pi over 4. That is the same thing, according to this up here, as just cosine of 3 pi over 4. Okay, so when I'm looking at my unit circle, find your 3 pi over 4, and I'm looking for the cosine of 3 pi over 4. That's the x value. So negative square root of 2 over 2. And then I've got, oh, I wrote this wrong. It's, I'm pretty sure. Let me look at number 17 real quick. Number 17, yeah, I left off my degree. So I'm going to bring this over so you can see what I'm talking about. That just said, before I put that in there, I just had written tangent of -135. Well, that would mean it's in radians, not degrees, and I was a little worried about doing 135 as an exact value, so I was correct that this was wrong. It was supposed to be degrees. So the tangent of 135 degrees, again, I'm going to consult this value right here, 135. And remember, your tangent is your y over your x. Y over x, or sine over cosine. So I have a square root of 2 over 2 divided by a negative square root of 2 over 2, right? Except, remember, okay, so hold on. This is a negative. So I'm going to use this rule up here and say that's really negative, whatever this ends up. Tangent of 135 degrees. Okay, so I'm going to have negative whatever I get when I take square root of 2 over 2 divided by negative square root of 2 over 2. Well, it's the same thing divided by itself, which makes it 1, and one of them was negative. So that's a -1. But then, again, it was negative, so that means it's a +1 overall. Okay. The last one that they give me is this number, or the last one that I'm going to have you guys do for this part of the lesson. I'm actually splitting this up into 2 separate assignments because there's a lot in this lesson. So let's just deal with this one first. This one is wanting me on number 23. They want me to verify the identity by transforming the left-hand side into the right-hand side. So we've done that before where we had to... Not used to hearing those bells. All right, so we have to change this left-hand side to make it look like this. So the first thing I'm going to do is get those negatives out of there because that's weird. So I'm going to do negative cotangent of x over negative cosecant of x. So again, cotangent and cosecant are both ones where you can just put your negatives up front. So that's what I did. And that equals my cosine of x. So the first thing I'm going to do is cancel those negatives out. The other thing I'm going to do is I'm going to rewrite this as a division problem. This is really cotangent of x divided by cosecant of x equals cosine of x. And I'm doing that so that I can write these as fractions and then flip and multiply. Okay? Again, I'm leaving this over here exactly the same, never changing it. So cotangent is 1 over tangent, and I'm going to divide that by cosecant, which is 1 over sine. Okay, so that really means I have 1 over tangent times sine over 1. Okay, the other thing I have to think about is that if I have a 1 over tangent, tangent is really sine over cosine, right? So let me get this together in one fraction. So I've got sine of x over tangent of x. I couldn't simplify anything yet, but I'll be able to. This really means I've got sine divided by sine over cosine. Okay, so again, I'm just leaving that the same, but this right here, tangent is the same thing as sine over cosine. So I'm taking sine and I'm dividing it by sine over cosine. So I'm going to put this over 1. So this is really sine of x over 1 times cosine of x over sine of x. And then that sign simplifies. So now I'm down to cosine of x over 1, or just cosine, equals cosine. So now I verified it. Okay, so that was a lot of work to get through there. Just start using all of your identities that you can possibly use. So first I used that negative idea, then I used these reciprocal ideas, then I said, well, tangent is the same thing as sine over cosine. So I just did whatever I could do to get to cosine. Okay.